Hello. So in the last video we had a very brief look at some of the theory of electrical circuits and saw how the voltage is trying to push a current through the circuit and the resistance is trying to slow it down. But what does that mean in practice? Well, to explore that, I've got one of these things. This is a breadboard. I'm going to build my computer on one. And the way it works is all of these little holes here are things you can push components into, and all these little vertical ones are connected together strip by strip. Across the top here you've got some buses which are you can see the top one's marked plus, the bottom one is marked minus, and we've got another plus and a minus down the bottom here, and all of these are connected all together. The easiest way to show you how this works is to connect it up and see. So I've got a power supply here, just a little power supply, which is going to supply 5 volts, although once we know that it's 5 volts we can then more or less forget it. So if I plug it in to the plus at the top and the minus, when I plug this in we should now have a position where we've got 5 volts across these two rails. Of course I can bring that down here as well, so I can plug in the plus and minus up here. I do that, and then I can plug them in down here, and then I've got both power rails working, and I can connect up all the electronic components that I wish to. Now, just to see if that's working, we're going to bring in one of these. This is a cheap multimeter, and what that does is it measures voltage. What I've done is I've put the probes into a chocolate box, and then I've just got a couple of these little jumper wires coming out. By the way, I am going to give a full list of all the components I use, but not on this video because this is just to demonstrate. But when I actually get to building the computer, there will be a list at the end of every video of every component I've used, just in case you feel like building along with me. So let's switch this on. Okay, select DC, and we're going to do some probing to see what our voltage is. First of all, I better plug my power supply in, like so, and let's have a look and see. So let's plug our negative probe into one of the negative slots and the positive probe into one of the positive ones, and we can see that we've got a voltage of about 5 volts. If I take the positive probe, I can now take the positive probe, and if I put it into the ground, you can see I've got no volts. So in discrete logic chips, that's what they're looking for. They're looking for some voltage or no voltage. There is a third option, which is to have the sort of end floating around at, just out in the wild. You'll notice the multimeter says no volts still, but to a logic chip that can actually be a third type of signal, and we generally don't want that. So when we get onto logic chips, you will see that I tend to tie things either specifically high or specifically low, and I try not to just let it float around like that. By the way, I can also check it down here, so I can check that this is high, which it is, and I can check that this is low, which it is, so I've got power all round. Now, I'm going to unplug the power supply for this one, because I'm going to show you something which you definitely should not do. So, one thing you very much should not do is to connect the positive directly to the negative. There's basically 2 reasons for that. Firstly, if you connect it to both high and low at the same time, I mean, how do you know which signal it is? Is it high or is it low? And secondly, do you remember we said that the resistance is trying to slow down the current? Well, there's very, very little resistance in this wire, okay? So what you're going to get is you're going to get really quite a high current flowing, which is going to heat everything up, and if you put a high enough current into a chip, you will get magic smoke coming out the top, which is generally considered to be a poor idea, and the chip will no longer work. So, in order to get around that, we're going to use one of these. This is a resistor. all it does is it slows the current down. And we're going to use quite a lot of these around and about the place to slow the current down. And let me give you an example. So if I plug the one end into negative and the other end into one of these little slots here, I can then get this thing, which is an LED. This also needs to be protected with a resistor. Okay, LEDs have got, if you have a look at the bottom, I don't know if you can see, but they have a flat on one side, and they have one long pin and one short pin. This is the short pin, that's the long pin. The short pin and the flat side is the negative there. That has to go towards the 0 volts. So let's put that towards the 0 volts, and then I'll plug the LED into one of these upper little slots here, and then just reconnect the power supply. If I connect the LED from where it is into the positive rail, nothing happens. What have I done? Let's have a look and see. What I've done is not pay attention and plug them into different rails. But if I then plug that in, oh look, the LED lights up. Okay, so that is now power going from negative through the resistor to here, through the LED to there, up to positive, or back the way in fact, and lighting it all up. Brilliant, well done us. Now, when we're dealing with logic chips, we want a way to give them high or low signals. So let's have a look at a way to do that. So, let's have a look at this thing. I've got a resistor going through an LED. Now what happens if I get this thing, which is a switch, okay, and I plug it carefully into the circuit. So let's put it there for the moment. Okay, and now I'm going to take the LED across to one of the terminals of the switch. Okay, and then I'm going to take the other terminal of the switch and I'm going to plug it into the power. And obviously nothing happens, but if I push the button and properly look at what I've done, better, so actually connects together. If I push the button, the LED will light up. And again, that shouldn't be sort of rocket science, but if I bring it back here and we pretend that this thing now is our logic chip, I can plug one end into ground and I can plug the other end into this bit here. And as you can see, at the moment it's connected through the LED and the resistor down to ground, so we're getting no volts. But if I push the button, and again, sorry, I'm sort of doing this from slightly off camera, which means I basically can't see what I'm doing. Let's try that again. Okay, you can see that I'm getting no volts, more or less. High, low, high, low, high. Okay, so what I'm in fact doing with this resistor is I am using it to pull up the voltage whenever I want to high, and then whenever I don't want, it pulls it down. Now, in fact, I can do that the other way around. So if I were to connect the LED into, and I'm going to tilt the thing so I can actually see, into the switch like that, and then into the positive rail like that. Sorry, clumsy. And then if I were to connect the other end down to the ground like that, we should still have a situation where when I push the button, the LED lights up. And if I check it, just to make sure I've got it all right. Hold on, sorry. Oops, sorry. Then that is exactly what I have. Okay, but now let's probe using our voltmeter, and we'll stick it into where the LED is. Now this time it is connected through the LED up to the power rail, and you can see it is showing some volts. But when I push the button, it will then immediately connect it down to the bottom, and you can see it's showing no volts. So this switch is the other way round. It's high and then low, high and then low. And actually chips use both sorts. They use active high signals and active low signals. So chips need signals that come in that are that do something when it's high, and they need signals that come in that do something when it's low. So in the next video we're going to have a look at some logic chips. We're going to have a look at how you might connect them up on a circuit board, and we're going to have a look at see if we can do anything about these great big long floppy jumper wires, which are quickly going to become extremely annoying in a circuit board situation. So that's the next video, and I hope to see you then. Goodbye.